Good evening. It is day 2 of Advent of Code. That's irrelevant. um, let's take a look at today's challenge. It's up in 53 seconds. Yikes, I'm super unprepared. I've got my little template here for part 1 and part 2. I've just copied it over from day 1, and I'm ready to go just about. So, Advent of Code is a daily advent calendar for the month of December oh shit, there we go. That has coding problems that get progressively harder as we go through the days of December. So that's cool. That's what it is. This is getting underway here in just a minute, 10 seconds to be exact. Just trying to make sure that my stream is working. It's really hard to tell, but 3 seconds, 2, 1, we're going. Maybe we're going. If we can load the page, we'll be going. Am I like on VPN or something? No, I'm not. Wondering why this is taking so long to load. Is it just my internet, or is it... No, it seems to be Advent of Code. Alright, well maybe we're down for the minute. There we go. Okay, cool. We're back. Yay. Red-nosed reindeer nuclear fusion fission plant. Okay. We really appreciate our help analyzing some unusual data from the reactor. Unusual data consists of many reports, 1 report per line. Each report is a list of numbers called levels that are separated by spaces. Okay, 6 reports, each contain 5 levels. Trying to figure out which reports are safe. It's not loading for you too? Yeah, it's up now. Should be. Can only tolerate levels that are either gradually increasing or gradually decreasing. So it's only safe if they're all increasing or all decreasing, differed by at least 1 and at most 3. Okay. Safe because they're all decreasing by 1 or 2. Because 2 is an increase. 2 to 7 is an increase to 5. 6 to 2 is a decrease of 4. Cool. So, valid if all increasing or all decreasing. Then we'll put that in parentheses. And go and difference is more than or equal to 1 and less than or equal to 3. Okay, analyze the unusual data from the engineers. How many reports are safe? Cool, so let's copy this over to our input. Cool, so we just need to check if they're all increasing or all decreasing. And if that's the case, we also need to check if the difference is more than 1 or less than 3. So let's do, for L and lines, we'll have total of 0. For L and lines, we'll do nums is L.split on, whoops, that's not what I meant to do, on space, n for n in L.split. So this is list comprehension. We're just converting all of the numbers to integers after we split them. And then we need to check if they're increasing or decreasing. So I'm going to assume that we have at least 2 numbers. So we'll do previous is num0, and for I in range, oh, we can just do for n in nums, and then we can slice it to go from the first element onward. We can do, so we need to tell if it's increasing or decreasing. And from there, we need to check if you know, like the magnitude by which it's different. So I guess the first thing we can do, we can just have increasing is num0 is less than nums1. And then we'll do if abs of n, whoops, we should do for I in range of nums because we want to index them. Actually, we can do previous. If so we're trying to get the difference here of the previous one in n is so it has to be at least 1 and at most 3. I'll do diff. I haven't LeetCoded in a while, and it really is becoming apparent as I'm doing these exercises. If diff is less than 1 or diff is greater than 3, we can just break here. Otherwise, and then we also need to check if we're increasing or decreasing. And then the other criteria is well, so we don't want to break quite. We want to, well, yeah, I mean, we can be done here at this point, and we know we're not adding to total. I'm going to be lazy here and have just a Boolean here. We'll just have valid become false here. And then at the very end, we'll do if valid total plus equals 1. The other thing we need to do is check if it's increasing. If increasing so this is a Boolean telling us if the previous is greater than the current. So we can check the same thing here if the previous is less than n. I think this will do what we want. False. And then finally we need to do the thing here where we set previous to n. And then let's print total at the end here. And it's Python 3. Okay, so let's give this a go. Day two. CD day 2. Come on. No, I hate PowerShell. Python main.py 2. Okay, that seems to do what we want. So let's get our input. Oh no. Oh no. Advent of code, no. It's always been so reliable. There we go, okay. Ooh, I may have made a bad assumption. No, it looks like we have a minimum 5 in all of these. I don't feel great about this solution because it feels kind of flimsy, but we'll see if it works. 246. Oh. Wow, so this might be exciting. It seems like they're having trouble scaling. Oh, look, that was actually right. Pretty epic. Cool. Yeah, there seems to be some server gremlins they've got to work out here. Okay, they're surprised by the low number of safe reports until they realize they've got to tell you with a problem dampener. It tolerates a single bad level in what otherwise would be a safe report. Okay, the same rules apply as before, except if removing a single level from an unsafe report make it safe, the report instead counts it as safe. So safe without removing any level, unsafe, safe by removing the second level 3, safe by removing. Oh, okay, so this, that's kind of hard. I'm wondering if what if we just call this invalid, and then we do invalid plus equals 1 here, invalid plus equals 1, and then if invalid is less than or equal to 1, we can increment the count there. So what I'm doing there is we're allowing just one of the things to be invalid. I'm wondering if that will work though, or if we have to like actually consider the list with that value removed. But I think that's sort of the same thing. So let's see if we get the same answer for here. Oh, you know what? I did it wrong. 6. That doesn't count. Or that's not correct rather. If invalid is less than or equal to 1. Oh, what if we just continue here? So this is saying, this is effectively, if we don't count the first one, we don't consider it in the second one. Okay, so I'm convinced that maybe works. Let's give it a go and see. 294? This is not gonna be right. Yeah, okay. That's fine. Cool, so let me put this back to how it was for part 1. And then I'll actually just move this and have it be in part 2. Like we're supposed to. So, unsafe regardless which level is removed. Safe vibrating the second level 3. Okay, so I think we might actually have to do the thing here where I really don't want to do this. We could just brute force it though. There's not very many of them. I'm thinking we just try all the permutations of the list, which really sucks, but let's see. Yeah, I don't love it, but I think I'm gonna do it. Part 2. Yeah, okay, so for Ellen lines, let's do there's like some permutation Pn. We'll make a new function. Def get permutations L. So we'll do for I in range length of L. We will do result.append, and this will be L 0 to I to, ooh, can you slice it like this to, what can I do here? So I want to splice out the ith inter element from L here. So I want L to I, so I think I can do this plus L I plus 1. Let's try that. Permutations of L. We'll do the same thing. And then if we, then we can break here for p.split. So before we do that, we'll do part 2 lines. Whoops, no, we can do just get permutations. Go return result at the end here. So I'm just checking my function here to get the permutations. Lines 0. This is a really bad way of doing it. But I think it might do what we want it to do. Okay, let's see. So we've got, what? Oh, because we haven't. Yeah, no, we gotta do this first. For Ellen lines, we do the thing here, and then we do nums 0. No, we want to do nums. Skip permutations of nums. Then we can return in L.split. 72, 75, 78, 80, 79. 69, 75. Okay, that seems to do what I want it to do. Cool. All right, so like I said, really bad way of doing it. We're essentially just getting all the lines or all the permutations of the given line and then checking each one, which is super inefficient. I'm sure there's a much better way of doing it, but turn my brain off and just brute forcing it. Okay. For permutation and get permutation of nums, we want to do p that should do it. If the total is that, then it's cool. That's not what I want. Save that. Do it on the test. 4. Okay. So I think that'll do what we want. 318. Final answer. Great. Okay. So, there we go. We've done it. It looks like Advent of Code has maybe recovered. Oh. Yeah, okay. Looks like things are not falling over so much anymore. That's the first time I've ever had an issue with Advent of Code. You know, server errors. So that's kind of interesting. But it looks like they fixed it now. Let's see how we're doing on our leaderboard. This. Woohoo! Back on top, baby. Seems like people are having... well, actually, looks like nobody else has really attempted it yet today. I was going to say, it seems like people are having more trouble with it, but nobody's really done it so far today. This did kind of feel harder than previous years' day 2s, though. There's probably a really easy way of thinking about part 2, but I couldn't find it. Actually, I know for a fact there's an easier way in Python of getting the function, of getting like permutations of an array excluding an element. I think you could do something with... I forget the name of the built-in function, but it's our library function. Anyway, yeah, part 1, pretty straightforward. Just a few rules we had to apply. Part 2, a little bit more complicated. Same thing, except we get to ignore an element. And it's not just as easy as saying, okay, we have one element, you know, one time it doesn't match, we can continue and check, you know, and see if there's another time that it doesn't match. You have to actually remove, you know, simulate removing the element from the array, and then see if it works. So yeah, fairly straightforward, but a little bit of a hacky solution that I've come up with here. This is gross. I wouldn't recommend this. This is the kind of thing that in future days is not going to go well because it's going to become computationally intractable very quickly. But there we go. We are done with day 2. And I'm going to call it there. Happy Sunday evening, everybody. Thanks for tuning in, and I will see you all same time, same place.